Jai Hind everyone. I am Dublish, faculty of MC department in AKG Engineering College. Today I am going to deliver a lecture on web technology, and my topic of today's lecture is IOC and dependency injection, it is a very important topic for all BTech, CSIT and MCA student. So first of all, what is IOC? The full form of IOC is basically inversion of control. Basically, IOC container is a framework for implementing automatic dependency injection very effectively. So it manages the complete object creation and its lifetime. Also, it also injects the dependency into the classes. So basically, IOC pattern to implicitly provide an object reference in a class during runtime. So this pattern acts as an alternative to the service locator pattern, and the IOC container contains assembler code that handles the configuration management of application object. Basically, two Spring Framework provide package, namely org.springframework.beans and org.springframework.context, which help in providing the functionality of IOC container. So IOC container provide firstly a bean factory, and second one is application context. Now, difference between the bean factory and the application context. So the org.springframework.beans factory, basically bean factory and the application context interface act as the IOC container. The application context interface is built on the top of the bean factory interface, and it adds some extra functionality than bean factory, such as simple integration with Spring AOP and message resource handling, event propagation, application layer, specific context, that example web application context for web application. So it is better to use application context than bean factory. Now, what is the use of bean factory? The XML bean factory is the implementation class for the bean factory interface. To use the bean factory, we need to create the instance of XML bean factory class as given below. We have resource is equals to new class path resource. We will add the class path in there. Suppose I have write application context.xml. Now we will create the object through new, and the constructor of the XML bean factory class receive the resource object. So we need to pass the resource object to create the object of bean factory. And through application context, the class path XML application context class is the implementation class of application context interface. So we need to instantiate the class path XML application context class to use the application context as given below. So the application context is equals to we'll add the class path, and the constructor of the class path XML application context class receive string. So we can pass the name of the XML file to create the instance of application context. So basically in IOC container, we use the bean factory and the application context, which I told you earlier. In the IOC container, we have bean factory and application context. Moving on, dependency injection. Now the question arises, what is dependency injection? Basically, dependency injection is a design pattern used to implement IOC. It allows the creation of dependent objects outside of a class and provide those objects to a class through different way. Using dependency injection, we move the creation and binding of the dependent object outside of the class that depend. Basically, dependency injection pattern involves three types of class. First, we have client class. Second, we have service class. Third, we have injector class. So, what is client class? Basically, client class is known as dependent class, is a class which depends on the service class. As its name explains, it's a dependent class. So, it must be depend on our service class. Service class known as, we can say it's dependency that provides service to the client class. Injector class, the injector class inject the service class object into the client class. Now, through this figure, we can illustrate the relationship between these class. Client uses service and injector inject all the services in the client. So as we can understand, the injector class create an object of the service class and inject that object to a client object. In this way, the DI pattern separate the responsibility of creating an object of the service class out of the client class. Now, the types of the dependency injection. As we know, the injector class inject the service dependency to the client which is dependent. The injector class inject the dependency broadly in three ways. We can create through a constructor, or through a property, or through a method. So basically we have three type of dependency injection. First one is constructor injection, second one is property injection, third one is method injection. Now, what is constructor injection? So in constructor injection, the injector supplies the service dependency through the client class constructor. And the property injection, in property injection, the injector supplies the dependency through a public property of the client class. And method injection, in this type of injection, the client class implement an interface which declares the method to supply the dependency, and the injector uses the interface to supply the dependency to the client class. Now, aspect-oriented programming, also known as AOP. Now, what is AOP? Basically, AOP breaks the program logic into distinct parts called concern. It is used to increase modularity by cross-cutting concerns. A cross-cutting concern is a concern that can affect the whole application and should be centralized in one location in code as possible, such as transaction method management, authentication, logging, and security. Now, what are the terminologies in which we used in aspect-oriented programming? Aspect-oriented programming terminology. First one we have aspect. So, and second one join point. Now, what is aspect? Basically, aspect is a module which has a set of API providing cross-cutting requirement. For example, a logging module would be called AOP aspect for logging. An application can have any number of aspects depending on the requirement. And the join point represent a point in your application where you can plug in the AOP aspect. You can also say it is the actual place in the application where an action will be taken using a Spring AOP framework. Third one is advice. This is the for a point cut and introduction. Advice is the actual action to be taken either before or after the method execution. This is an actual piece of code that is invoked during the program execution by Spring AOP framework. And point cut, this is a set of one or more join points where an advice should be executed. We can specify point cut using expression or pattern as well, as we will see in your AOP example. And introduction allows you to add new method or attribute to the existing class. So last one is target object and weaving. Now, target object advised by one or more aspect. This object will always be a proxide object, also referred to as the advice object. Weaving means is a process of linking aspect with other application type or object to create an advice object. So this can be done at compile time, load time, or at runtime. Now, types of advice. So Spring Aspect can work with 5 kinds of advice mentioned as below. First one, before. Second, after. Then after returning. Through, after throwing, and last, around. Now, what is before? Run advice before the method is execution. After, run advice after the method execution regardless of its outcome. After return, run advice after the method execution only if method completely successfully. After throwing means run advice after the method execution only if method exists by throwing an exception. And around means run advice before and after the advice method is invoked. So these are the type: advice, before advice, after advice, and we have interceptor. Method before advice and after advice we implement after returning advice and throw advice, and method interpreter. So firstly we have method, which are method before advice, after returning advice, throws advice, method interpreter, and then we have these method of advice, before advice, after advice, and interpreter, and all these are linked to the advice. Now what is bean? So the object that form the backbone of your application and that are managed by the Spring IOC container are called beans. A bean is an object that is initiated, assembled, and otherwise managed by the Spring IOC container. So these beans are created with the configuration metadata that you supply to the container. So bean definition contains the information called configuration metadata, which is needed for the container to know the following. Firstly, how to create a bean, bean lifecycle detail, or bean dependency. Now, bean scope. Bean scope refers to the lifecycle of bean that moves when the object of the bean will be initiated. How long does the object live and how many objects will be created for the bean throughout. Basically, it controls the instance creation of the bean and it managed by the Spring container. So the bean scope in the Spring is the bean Spring framework provides 5 scope for a bean. We can use 3 of them only in the context of web aware. First one is the Spring application context, and the rest of the 2 is available for both IOC container and Spring MVC container. So we have basically different scope provided for a bean. First one is singleton, second one is prototype, request, session, and global session. Bean scope. First one, singleton. Only one instance will be created for a single bean definition per Spring IOC container, and the same object will be shared for each request made for that bean. Prototype means a new instance will be created for a single bean definition every time a request is made for that beans. Request method means a new instance will be created for a single bean definition every time an HTTP request is made for that beans, but only valid in the context of a web-aware Spring application context. Session. Scope a single bean definition to the lifecycle of an HTTP session, but only valid in the context of web-aware Spring application context. And global session means scope a single bean definition to the lifecycle of a global HTTP session. It is only valid in the context of a web-aware Spring application context. Now, we will discuss in singleton in detail. If the scope is a singleton, then only one instance of that beans will be initiated by Spring IOC container, and the same instance will be shared for each request. That is, when the scope of a bean is declared singleton, then whenever a new request is made for that bean, Spring IOC container first checks whether an instance of that bean is already created or not. If it is already created, then the IOC container returns the same instance, otherwise it creates a new instance for that beans only at the first request. By default, the scope of bean is singleton. Now the prototype scope. If the scope of is declared prototype, then Spring IOC container will create a new instance of that beans every time a request is made for that any specific bean. A request can be made to the bean instance either programmatically using getBean method or by XML for dependency injection of secondary type. Generally, we use a prototype scope for all beans that are stateful, while the singleton scope is used for all the stateless beans. Now, the question arises, what is the difference between singleton and prototype scope beans? In singleton, only one instance is created for a single bean definition per Spring IOC container, but in prototype, a new instance is created for a single bean definition every time a request is made for that beans. In singleton, same object is shared for each request method for that bean. That is, the same object is returned each time it is injected. But in prototype, for each request, a new instance is created, and that is, a new object is created each time it is injected. In singleton, by default, scope of a bean is singleton, so we don't need to declare a bean as a singleton explicitly. But in prototype, by default, scope is not prototype, so you have to declare the scope of a bean as prototype explicitly. But in singleton, scope should be used for stateless beans, while in prototype, scope is used for all beans that are stateless, that are stateful. So the life cycle of Spring Bean is very important, and we should understand in very easy method. So when a bean is initiated, it may require to perform some initialization to get it into a usable state. Similarly, when the bean is no longer required and it is removed from the container, some cleanup through there are list of the activities that take place behind the scene between the time of bean initialization and destruction. We will discuss only two important bean lifecycle callback methods which are required at the time of bean initialization and the destruction. To define setup and tear down for a bean, we simply declare the bean with init method and or destroy method parameter. The init method attribute specifies a method that is to be called on the bean immediately upon initialization. Similarly, destroy method specifies a method that is called just before a bean is removed from the container. Thanks.